Greetings from GNU Linux Users Group, NIT Durgapur. Welcome to the very first video of our cryptography series, which is one of the important categories involved in cybersecurity. So buckle up to dive into the cryptic world involving ones and zeros. First and foremost, cryptography is everywhere, from the Roman and Egyptian times to the Enigma machines in World War II, from simple Caesar ciphers to the present digital world in which information is of the highest value. It has applications in all the fields out there. To name a few, cryptographic techniques are used for end-to-end encryption in emails, social messaging app, while storing data in databases, authentication, digital signatures, electronic money, and a lot more. As a simple example, Alice wants to have a chat with Bob, but they are not so sure that if anyone is interfering with their conversation. Maybe someone Eve is listening to their private conversation. What should you do? Cryptography. Maybe you are an army general and you want to pass on an important classified order. How do you make sure your enemy doesn't get it? Cryptography. So, before moving on, these are the things we will be discussing today. What is cryptography? Bits, bytes, hex, base 64, base 32, ASCII, and then some of the cryptography principles and terms, ancient ciphers, including Caesar cipher, and at last encoding versus encryption. So, what is even cryptography? Cryptography or cryptology is the practice and study of techniques for secure communication in the presence of adversarial behavior, the art of writing or solving codes. Why is cryptography needed, you ask? For a secure world. To have a better understanding, if you haven't already, do check out our Cybersecurity Introduction to CTS video, which lays out a great foundation. Moving on, it would be great if you make yourself aware of some of basic stuff, which will definitely help you out in the long run. These are bits and bytes, hexadecimals, and with that some of the popular forms of encoding like base 64, base 32, and also ASCII. And we will be seeing these in Python. So, as you may have already know, bits and bytes are the building blocks of our digital world. Thanks to the transistors and physics, but essentially they are just ones and zeros. And hence the name binary digits, which is base 2. So 101, which is binary, is 5 in our decimal system. And then a byte is 8 bits, which means it has a maximum value of 255. If you wonder why 8, it's just a standard we all have agreed upon long ago. So how do you do it in Python? Today I'll be using bpython, which is just a wrapper on top of Python that makes stuff look fancy. So in Python we represent binary numbers with a prefix of 0b. So 0b101 now represents a binary number, and these are of type int, and so you can perform all sorts of operations on them as you would do with numbers, because even binary numbers are numbers, right? Now there is also a bytes type in Python specifically for bytes. It's different from what we have seen for binary. These are represented with a prefix p to a string. So you can see a type of a b prefixed string is bytes, whereas if you don't have the prefix, the type would be a string. Unfortunately, you cannot perform some operations directly on bytes, but you can do if you convert it into a int type. This is because byte is considered to be a form of data, whereas binary is considered to be numbers, at least in Python. So going ahead, we have hexadecimals, in short hex. Yes, these are nothing but base 16, which is the numbers 0 to 9 and letters from A to F. And so 4E is 78 in decimal system. Also, since 16 is 2 to the power 4, each hex character represents 4 bits, and thus you can represent a byte with 2 hex characters. So in Python, it is represented with a prefix of 0x, similar to binary. It is also of type int, and you can perform all sorts of operation on it that would you would do on a number. Also, on a side note, while working with cryptography in Python, always work with bytes instead of strings. And when you want to print bytes, encode it in hex. This way, it's easy to debug and things look nicer. To convert a byte string to hex, you can simply use the dot hex method and use bytes from hex method to convert it back into bytes. And so, for humans, looking at bytes in hex is easier as it takes less space and also looks nice. Okay, about bases. Whenever we say base n, it means that there are n characters that map to n numbers. Luckily, we don't have to choose those characters ourselves because those are already specified publicly in standards. So clearly, binary is base 2 and hexadecimals are base 16. Similarly, there are also base 32 and base 64. Specifically, base 32 has characters of 26 alphabet and then numbers from 2 to 7. Similarly, base 64 has characters of 26 capital case letters, 26 lowercase letters, and then numbers from 0 to 9, and then two of the special characters plus sign and forward slash. It would be great if you are willing to have some understanding of how do you encode or decode in base 64 or base 32, but for today we are going to just see an example. Specifically, base 64 is a popular form of encoding and it can be seen at many places. There are a lot of tools and libraries out there that you can use to play around with. Let me quickly give you a brief demo in Python. With Python, you already get a module called base64 which for along with some of the other encodings has functions to encode and decode in base64 and base32. Before moving on, a few minutes before I told you that always work in bytes. So let's work in bytes. So now let's first import base64 module and encode the byte string hello world. And then which is of type bytes, so base64.b64 encode. As you can see, the return type of the function is also of type bytes. Now let's decode it back. And you have guessed it, it's base64.b64 decode and then this, and voila, there is our hello world. Similarly, you can play around with base 32. And now, moving on to ASCII. It stands for American Standard Code for Information Interchange, which is just a bunch of characters getting assigned a number. It is 7-bit and so it has 128 such mappings. For example, the character capital A is assigned 65. So for us, it is capital letter A, but for computers, the same is 65. Now, in Python, there is a function available in the global namespace ORD, which stands for ordinal, converts a single character to its assigned number. So odd A gives 65, and the reverse for this is the function CHR. So CHR 65 give us the capital letter A. So, is all this cryptography? No, this is far from cryptography. There is no key for this. These are merely just converting one form of data into another. For that matter, all these representations, binary, hex, base 64, base 32, ASCII, are essentially equivalent to a computer. Moving on, here are some of the terms and principles which you would often encounter and will help you better understand cryptography. So, plain text, the data or message we want to encrypt, or in other words, the sensitive data we don't want publicly revealed, of course, except to the desired receiver. Ciphertext, encrypted message which can be publicly revealed since it doesn't make any sense unless decrypted. Key, an important piece in the puzzle, is some parameter upon which the whole security depends. Kerckhoffs's principle, it states that even though the logic behind a crypto system is known, it should be difficult to crack it, or in other words, it should be secure. Key space, the set of all possible keys. Cryptanalysis, it is an art of deciphering coded messages without being told the key. Note that this is not an exhaustive list. You will always find something that you don't understand. The key is to search for it and keep learning. So to end with, let's have a brief look towards some simple ciphers. These are specifically ancient ciphers. Why are these called ancient ciphers? Because these were used historically, and in contrast to the modern cryptographic algorithms, most classical ciphers can be practically computed and solved by hand. So, Caesar cipher is nothing but shifting letters over by some number. So, if the shift is 2, then A is C, B is D, and so on. Substitution cipher just create some one-to-one random mapping from one letter to another letter of the alphabet. Vigenere's cipher, it is just one level above Caesar cipher. Each character is shifted by a key phrase rather than just one number. And now, adding to the previous, let's analyze Caesar cipher a bit more. Here is a simple visualization of the shifting. Now, if you increase the key to 13, you could see something special. Each letter has some sort of inverse letter. A maps to N, and then N maps to A, B maps to O, and O maps to B, and so on. The key in this cipher is obviously the shift, because the whole security of Caesar cipher depends on it. Even though you can crack it as the key space is literally only 26, you can easily go over 26 even by hand. So if you apply some mathematics, Caesar cipher is essentially an encryption function e of x, where x is the number of the character that we translate to, like a is 0, b is 1, c 2, and so on. So e of x is equal to x plus k modulus 26, where k is the key or shift, and the output of this function is some numbers, which is then translated back into characters. And similarly, the decryption function is x minus k modulus 26. Why does 26 appear here? It is because there are 26 letters. Now let's have a quick distinction between encoding and encryption. Both may seem similar, but they are not. Encoding and encryption are two totally different things. Encoding transfers data into another format using a scheme that is publicly available so that it can easily be reversed. Encryption transforms data into another format in such a way that only specific individuals can reverse the transformation. Encoding is for maintaining data usability and uses schemes that are publicly available. And encryption is for maintaining data confidentiality and thus the ability to reverse the transformation. Keys, that is, keys are limited to certain people. So with this, we have reached the end, but it's just the beginning. In the next video, we will be discussing about modern cryptography, so make sure to subscribe and thank you for watching. If you have enjoyed the video or learned anything, leave a like and shoot your doubts in the comment section below. Until then, may the source be with you.